Here's an exponent question. It says if 3x minus y is equal to 12, what is 8 to the x divided by 2 to the y? Now, if you're like most of my students, they take a look at this and think, how in the heck can you solve this? We don't know what x and y is. We've got two variables in this equation, so we can't solve down for either one of them to substitute in over here. So let's review our exponent rules and see if that's going to help. First rule of exponents is you have to be working with the same base. So if we've got the same base and you're multiplying exponents, multiplying bases, you end up adding the exponents. So 3 to the second times 3 to the fourth is the same as 3 to the 2 plus 4, 3 to the sixth. If you do not have the same base, like 2 to the third times 4 to the sixth, you're dead in the water. This will not work. That doesn't turn into 8 to the ninth like some of my students try. It doesn't work. So the first rule is you have to have the same bases. So as long as we have the same base, again, when we are multiplying, we end up adding the exponents. So 3 to the second times 3 to the fifth is same as the 3 to the 2 plus 5, or 3 to the seventh. Our exponent rule also applies when we're dividing. When we're dividing, instead of adding the exponents, we come here and we subtract the exponents. So 3 to the 8th divided by 3 to the 3rd is the same as 3 to the 8 minus 3, or 3 to the 5th. This also works for, we can go into negative here. So for example, if we had 3 to the 4th divided by 3 to the 7th, that's the same as 3 to the negative 3rd. By taking 4 minus 7, that would give us negative 3. So multiplying, dividing, or raising to a power. Raising to a power, that's when we multiply our exponents. So 3 to the 4th raised to the 3rd is the same as 3 to the 4 times 3, or 3 to the 12th. Now, notice again that we have to either multiply, divide, or raising to a power. If we're either adding or subtracting the same base, our exponent rules don't apply. So here, if we had 3 to the 4th minus 3 to the 2nd, we couldn't solve it with exponent rules. We'd have to actually do out the math and solve it that way. So exponent rules, again, do not apply when you're adding or subtracting bases. They only apply when you, number one, have the same base, and number two, you're either multiplying, dividing, or raising a power to a power. So given all that, let's go back to our original question. Now we've got 8 to the x and 2 to the y. Do you see we have different bases here? In order for us to work and use our fancy exponent rules, we have to have the same base. So can we rewrite 8 in terms of base 2? Let's say 2 times 2 is 4, and then 4 times 2 is 8. So 2 to the 3rd is the same as 8. So 2 to the 3rd raised to the x divided by 2 to the y, we're just rewriting the expression. And now based on our exponent rules, we know that 2 to the 3rd raised to the x is the same as 2 to the 3x, because we're just multiplying 3 times x, over 2 to the y. Now we also know when we're dividing, we've got the same base and we're dividing, we can subtract the exponents here. So that turns into 2 to the 3x minus y. Look at this. 3x minus y, they've given what that value is. So 2 to the 3x minus y is the same as 2 to the 12th. Cool. And that is answer A, and that's the right answer.